And welcome to Desk of Ladyada.
Hey everybody, welcome to, oh that's cool, I've got this like green, I've got a green band-aid on and it's black. Welcome to...
You're transparent and open source as always, Ladyada.
So it's Desk of Ladyada time. I know it's Saturday night. Tomorrow we want to, I'm going to go see dinner with a friend.
We're going to talk about electronics and engineering with one of Lamore's MIT friends, which is exactly what we wanted to do for the last 18 months. So we're going to do that.
We're going to do that, and after I drink all that shochu and eat all that bibimbap, I don't want to come back here and try to do videos. So we're going to do it Saturday night instead, which is fine. I'm much more focused and not drunk right now.
You're on it.
Let's do this. Okay, so we've got a couple things going on Desk Ladyada. First off, is there any news or updates you want to give?
This Wednesday, JP will be hosting Show and Tell. We have a normal Ask an Engineer. We have our shows on Tuesdays, Thursdays, and Fridays as well. And then we have this special Saturday one. Over the next 10 weeks, just because of the holidays and more, we'll probably be moving stuff around. Lady and I are doing some volunteer work during the week of Thanksgiving, and then we're also visiting an Adafruit team member who's in the hospital on Thanksgiving Day. So things are going to be a little weird, but we will continue to publish, share. Take it away, Ladyada.
Okay, cool. All right, so this last week, I'm back trying to get some more hardware done in a run-up to the holidays. And the Feather ESP32-S2, I finally, it's like a design from like a year ago, but we finally got the modules a couple months ago, the ones that have both flash and PSRAM. I didn't really want to release it until I got the PSRAM modules. I guess I could have, but I don't know. Whatever, it doesn't matter. To get the PSRAM capable modules in, and so I want to go to the computer really fast. I'll show. They're out of stock at this moment. Actually, it says in stock, but I don't believe it. Really? I guess we have some of the feathers in stock, which I didn't realize. The ones without the BME 280 sensor. And then we have two versions.
Yeah, that's pretty remarkable. Folks, you should probably pick up some. I mean, like...
I don't know that that's true. That seems a little unlikely. It was out of stock. Maybe somebody was working today? I don't know.
No.
Okay, well, anyways, maybe an allocation got undone. But... so we got the ESP32-S2 Feather and the one with the BME 280 sensor. I kind of made two versions of this. It's it's one PCB design, basically whether we place the sensor or not. There's a price difference, and I figured some people, care about the price difference. They want it cheaper or they don't. That said, I kind of like the version with the BME 280 sensor because it's kind of an all-in-one environmental Wi-Fi sensing thing. And I think, even though this wasn't designed for like ESP home or... remote node stuff. I think there's enough people that do those kinds of projects that it would be neat to have a version that had a sensor built in. And then I could also make a version with the BME 680, which also has a gas sensor. And they have, an AQI air quality algorithm that's available for the Espressif. It's a closed source binary blob, but it's available for the Espressif Tensilica chipset. So there was, if people remember from like a year ago, I designed 3 versions of this feather actually. So this one, a version with a TFT and then a version with a TFT on the back. And ironically, I never actually put together the version of the one with the TFT on the front till now. So let's go to the overhead and I can show the different versions. So this is the version without the BME 260. This is the normal feather. And it's got the BME 280 spot here, but it's not placed. And then here's the version that does have it placed. It's basically, we just program the pick and place whether or not to have that sensor pick and placed on. And then, this is the other product that we put in the store. So you can see it's displaying temperature, pressure, and humidity. So handy. It's got basically the top 3 environmental sensors people want. So then... the other version is this version, which has these very cute TFTs. Which it's funny, for like a decade I was like, oh man, I can't wait till I have like little TFTs, basically just like those little OLEDs. And they finally became available. I don't know. I think these are used primarily for like smartwatch bracelet workout things. Like the heart rate monitor / step counter thing. So this is the color TFT version, but I love this TFT because first off, it fits right in between the feathers, so you can see, it fits very beautifully. It's 240 by 135, so it's a good number of pixels. It's, basically equivalent to the 1.8 inch TFT that was one of the first TFTs we ever stopped. It's like product number 300. But it's tiny and it's IPS, so it looks good. And so this is a simple demo. So we did Arduino testing last week, and then this week we're doing, we did some CircuitPython testing. So this is you can kind of barely see it, but it's the Blinka with a star, and then it goes and gets our GitHub number of stars on the CircuitPython repo. Why this demo? Because it's not the Bitcoin demo that people apparently think we're destroying the planet by doing.
Yeah,
so we don't do the Bitcoin demo anymore.
So here's the thing, everybody. We've been looking for a really easy thing that everyone would recognize and say, oh, that's live data. And, sometimes new technologies come along and all these crypto things came along, and it was really easy to just be like, oh, what's the price? And then it has a date, and there's like, you could look back in time.
And it changes rapidly, which was another really good thing about it.
But here's what we've learned is there is no nuances anymore. Either you're, have fun being poor, you're not into crypto, or like you're burning down the planet. And what's has happened is people on Twitter has targeted and harassed our team. And so basically we're just like, well, let's just not have this on social media, but let's find something. Well, let's find something pretty good. I mean,
and what's cool is since we stopped doing that demo, people don't use Bitcoin anymore. So it's actually it worked out.
But the thing is, I just want everyone to know we'll always do the right thing, and we'll always try to make sure we don't polarize things. So we're not going to have that type of thing on any of the social media things. But this in particular is fine anyways. So GitHub stars. It's a community thing.
And it's a nice
I wish there was a no API needed weather thing, but it doesn't exist.
Yeah, that would be, of course, ideal, but there isn't any. Okay, so this is number of stars for CircuitPython repo, and it updates every minute. One thing that I noticed when I first put together this board definition, I actually copied the TFT definition from the TT-Go, which is a other ESP32-S2 board that has the same TFT, and I was like, okay, great, I'm just going to take that initialization and change the pinouts to match. And one thing I noticed is you see how the TFT is really slow to update, it has this really weird slow wipe refresh. So that's from when you draw bitmaps in CircuitPython, especially on this board where the flash memory is shared with the program memory, which is all the memory is basically shared on one chip. Fetching the data from the bitmap on the QSPI, if the TFT is rotated, it doesn't redraw linearly. It has to access the BMP out of order because it rotates it, and so it scans the BMP out of order. It just jumps around to get the scan line of that BMP for that location. Whereas if you, and it's not linear, it's 90 degrees, so it's accessing each pixel of the file separately. Whereas if the TFT is unrotated, it does the right math so that it can read the BMP linearly. BMP files, if you've ever opened them, they have the data linearly inside it, and so you can seek to get the pixel data you need, but it's ideal if you don't have to seek, if you can just start from the beginning and read the data out. So I was kind of how to fix this, and I thought it would be worth showing how to do that. So in if we go to Circuit
Computer
Python, I can show the pull request. So under let's see, it's under ports, expressive boards. Okay, so here I think it's under board.c. So there's this kind of thing with CircuitPython. What we do is when the TFT is built in, we have to initialize it before anything else, and so we actually have to have all the initialization data needed for setting up the TFT and drawing to it in the C code. We can't load a separate driver. So you can always, if you want to, have a driver that initializes the display using display.io, but it's kind of cute when it comes up automatically. So here we have the display init sequence, And the thing that you kind of end up having to mess with the most is the MAD control register, which is memory address. I think MAD is like memory address, memory addressing of display control register. And that's 36. So 36 is and this is like true across like almost every TFT display. So almost every TFT display uses like the MIPI standard commands, which is why, sometimes if you're initializing a display, people are like, oh, I initialized, this ST7789 with ILI 9341 code, and it came up. And sometimes it actually comes up and it's like rotated or it's weird colors, but you actually get like something on there, is because the commands are almost all the same for like getting out of sleep, for setting the gamma, for changing the orientation and stuff. So the MAD control register is what you do to twist around the display and determine what is orientation, like the native orientation. And what's really nice is that they'll let you, almost every TFT lets you set this register to say like, not only which corner is it, but which way it's flipped. MAD control also sometimes changes the RGB ordering. So like which, whether, like sometimes you'll get a display and you'll see, I actually kind of messed it up when I made the PR. I ended up swapping the red and green or something. And so that register kind of has a lot going on in it, register 36. But the hint that it was not oriented correctly is, here, this is actually the correct version. If I go to history. Okay, so this is the diff. But if you go down here, the rotation was set at 90 before. And by having the native rotation be 90, that's why the TFT, when it displays bitmaps, it gets like very confused, because it rotates the display, then it has to unrotate the BMP, and basically like, all the math gets a little messy. So, when I did the PR, I changed the init code basically from, I think it was 00, and I set it to like 08 or 60 or whatever. And you can look in the data sheet for like which way it is, although I'll say, because every time I bring up a TFT, I'm always like ending up messing with the MAD control register. And the only hint I have is just like sit there and just try, like just flip the bits until like it comes into orientation you want. So the good news is that I did fix that, and then I guess
I'm going to go to overhead.
Yeah. Oh, another nice thing is the Tina UF2 bootloader that we have. It's not easy to see, of course, but it tells you like,
this is nice.
There's a little bootloader symbol, so it's like in the bootloader.
So one of the things I really like is low-cost electronics running scripting languages like Python, USB-C, stem and connector, shows up as a USB drive, has a UI for the user, has a screen, has battery stuff. Like this is what we've been working
and
for
even says, like,
and working towards for the last 15 years.
Download a UF2 and drag it on. So I feel like if you have a device with a TFT, I like it when, if in bootloader mode, it would come up. So this is the new rotated MAD control. So the good news is that like I did fix one thing. So let me hit the reset button to get it to reset. So the good news is I fixed the speed. So you see it like draw the image immediately.
That is fast. Wow.
But I flipped the color, so yellow is blue. So I inverted the color or something. So I have to go in and like, again, I just have to mess with the MAD control register until I get it right. And that's, every bit is like flip, rotate, RGB, GBR, whatever color. So it's very, very common when you do a TFT. That's the kind of the register you end up sort of like poking at as much as possible. But if you're adding a TFT or CircuitPython board, try to get the rotation to be zero, like whatever you want the native rotation to be, have that, which is like, I want it to be, I kind of like this. I sort of feel like Feathers should have, the USB on the left and the battery up, and then this is the legibility, and the text shows up quite nicely.
These are design choices.
Design choices.
An engineer makes.
But just to be super clear, like this is not the native, like this top corner is not the hardware native 00. It's actually this way. 00 is supposed to be up here. So, you're rotating it.
Question, what size is the TFT?
This is like 1.1 inches
okay.
diagonal. But it's a nice display, IPS display.
All right, what's next?
Okay, so speaking of, one thing I wanted to talk about is these mini modules. Because I wanted to, people who are watching the show, a lot of them make hardware, so I wanted to give you guys a hint. So this ESP32-S2 module Again, I like it. I don't have a Rover. Super handy. Hold on, let me grab them. Okay, so there's 3 sizes to ESP modules. So this is the Rover, and this is the the largest version of the Espressif modules, and these are kind of common because they have the chip, PSRAM, and flash. And sometimes there's no PSRAM, but there's spots for the PSRAM and the flash, and so you can get these customized with any setup of PSRAM and flash you want. If you order enough, Espressif will send them to you. And then there's the Waroom modules, which look like this, which have the chip, and then they have either flash or PSRAM. And you're like, well, you need to have flash, right? But sometimes the flash is built in. And then the mini, you see the mini modules actually basically the same size. Well, the mini module, if you line it up, it's pretty much the same size as if you just cut off this extra flash chip. And this actually only has basically this circuitry on the right hand side here, the chip and the passives, and the crystal, because it has the PSRAM and the flash built in.
Okay, why not rotate the BMP so the hardware can render it natively?
Because when you open the BMP on your desktop, you want it to be the image, the stars are on the logos on the left.
Someone's going to have to rotate it.
Someone has to rotate it, but if you just do it natively, you only have to do it once, and it's always it's elegant. It's it's exactly what you expect it to be. Because I think people want to have I feel like having a landscape view is better than a portrait view. But yeah, if you wanted to do portrait, you do portrait.
You do that too. All right, what's next?
So this mini module is nice because it has the flash and PSRAM built in. That's why I like it. That's why I'm using it, because I really like the 2 megabytes of PSRAM. It makes IoT and memory not a problem because you can read massive JSON files, bitmap files, whatever, and store them in RAM. And you have 2 megabytes of RAM. It's so much that you barely even have to think about it. So if you're interested, this actually over here is not an S2. This is an S3. So the S3 is the next chip coming from Espressif, and this S3 is somewhat like the S2. It's again the next generation of the ESP32, but the S3 is a dual core and brings back the Bluetooth low energy support that was taken out in the S2. So it's they had the ESP32, super famous, dual core, Bluetooth, Wi-Fi, can do everything, but no native USB. S2 took away the dual core, took away the Bluetooth. S3 bring that back. So the S3 is the closest thing to it's an ESP32 but with native USB, which is I think great because it supports Teen USB and it's wonderful. And I just noticed that on DigiKey, if you search,
you want me to go to that?
Yeah, if you go to because I was actually what is the status of the ESP32? S2. So the 32S2 Mini, you can actually get the version that doesn't have PSRAM here. Although I'll say this version, which is the 4 megabyte, the N4R2 means PSRAM 2, flash 4 megabytes. They say they're going to have some in stock soon. It says looks like they have a reel coming soon, and they have more coming in February. So luckily, these are starting to make it into circulation. But the ESP32-S3, and I can kind of tell that they're going to be doing a lot of promotion with this chip. So I'm always talking about the NPI here. So there are some ESP32 Waroom and mini modules.
Is it time for great search?
It's not. This is a secret.
Oh, we're not going to do great search right now?
Well, no, we'll get in a second. But
Okay.
I wanted to give people a hint because I can't just on the great search because this is going to be gone by the time I refresh.
Oh, okay, so I get it. So right now, if people want this, you should go get it now. And then we're
Yes.
going to do the great search because we save that as another segment later.
This is secret. Yeah, I don't want to talk about this because
yeah.
it's
All right.
this
So,
is for
hey,
engineer
y'all,
samples only.
For the community, by the way, the community that watches Ladyada is awesome. These are some of the treats you get. Go get some right now. Go. Because there's going to be none.
Yes, for sure. If you want a prototype, if you want to develop with the S3.
What should they search for on the site to get to this?
ESP32-S3. Yeah, I didn't want to put this on the great search because I felt like maybe I'll do it later when there's more in stock. But these are really engineering samples only. These are not for large scale use yet. And there's also
go.
dev boards. Although I don't think. Oh yeah, so they have the dev kit.
Yeah,
so
so listen, the great shh.
This is the
We
dev
can
kit
talk
I've
about
got. So I recommend this one. Has got the dual USB.
351 in stock.
And
Weeks
they don't
from
have
now,
any other
people
dev
will be
kits.
buying these and popping the chips off.
You can. I mean, you can use this as and remove the room if you want. But they do have some more rooms in. Okay.
So
Anyway,
we're
so
gonna
that's
pretend that didn't happen and want to do research.
it was not a secret. It's
Okay.
just it did happen.
All right.
We were here.
Do you wanna do
Yeah.
it?
So let's
Okay.
go to the Great Search.
Okay, I'm gonna do that. Ready?
Yes.
Okay, I'm gonna do this intro.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Thank you, DigiKey. Every single week, Ladyada looks online at digikey.com and finds
Parts
the parts
that
And
you
we
can
call-
buy.
And we call that the Great Search. What
Yes.
is this week's Great Search? Ladyada.
Okay, so this week's Great Search is kind of, it's a 2-in-1. So one, Pololu, which is a friend company, they're in Nevada. They also do open source hardware and electronics. And they did a massive post about silicon shortages and lead times, and it's a great article. So go check it out on pololu.com.
Yeah.
And one of the things that they showed is like their stock levels for some chips, including MOSFETs. So I want to promote them. Also, please support Pololu. Their stuff is awesome.
So every holiday season and
and they
every
sell
time
it
they have
on
a sale,
DigiKey too.
we promote them. And, I'll say this to our, live viewers and everything. I really hope the maker companies and the electronic companies this holiday season maybe get together and cross promote each other, because like Adafruit doesn't have every single thing, and every year we post all the sales to other sites and everything. Pololu and Adafruit always do that together, and we try
Yes,
to
we're good
put the spotlight on Pololu. But there's this thing that happened. Like we all used to be a community, and it was smaller when we first started doing open source hardware together, like 15 years ago. And now everyone's a competitor, and like knives are out, and like there's people who don't even talk to each other anymore. I think given that we've survived the pandemic, and not everyone did, but given that like we're here now, some of us did. Maybe it's a good reset. So, anyways, this is part of the Great Search is finding the goodness in each other.
Yes.
In addition to this part, back to
Sometimes-
Ladyada.
You're searching for another good company. So their stuff is available on digikey.com as
Yeah.
well. So you can purchase through them. But please support Pololu. They do awesome robotic stuff. But I really liked they posted some really good information about their part shortages and how they're struggling. And they mentioned that even MOSFETs are hard to get. It's like the silicon shortage. Like I know that there was a blog post by Playdate, by Panic, and they were talking about how their STM32 F7 chip or H7 chip, whichever it is, it's like they got a lead time of 2 years. And I saw another company say, we have an FPGA and it's some crowdfunding project, and they're like, our FPGA is delayed also for like a year or two. But those are like the things you're popular because you hear about these chips and sensors being used in automotive. But we're seeing this too. Even MOSFETs, like even the most like jelly bean of parts, are getting hard to get, or you order them and you're not getting them. And I always found that a little bit weird because I'm like, if you make a, if you make a silicon wafer with MOSFETs on it, I mean, you're going to get like hundreds of thousands of them per wafer. I mean, they're very simple. They're easy to fab. But it could be that process is booked up. So one of the things that we actually were just this week I had to go and find an alternative for is for our prop maker featherwing. It's out of stock because we actually couldn't get there's not a lot on here, but we couldn't get the MOSFET that's used with turning on the RGB LEDs. So this prop maker wing, part of it, and of course when I designed this I was like, what's 3 N-channel MOSFETs, what's the big deal, how could they ever not be available? But we have a little RGB LED driver, and you can see this ultra high power LED. A lot of people who make sabers or props, they have a very bright LED. We just did a prop with it for Halloween that Pedro did, and they used an LED, and they said it compared to a NeoPixel actually kind of the point source created a nice effect. But to drive these LEDs, you actually have to use a very powerful N-channel MOSFET with a good power supply, because these LEDs can be 3 watts. They can be an amp per channel, or even more, maybe amp and a half for the red LED. So it's a sizable amount of current. So you want to drive it well. So here is the circuit design we had for the prop featherwing. So you see there's a N channel FET, and there's a light pull down, red, green, blue. Very small little choke resistor just to keep it from running away thermally. And we spec the DMG 3406. So let's go to DigiKey, and this is the part I can't get. But let's look at this specs. GMG 3406. So there's 2 versions available here, but I think it's just the reel size. It's how many is per reel. And yeah, one of the tricks I've done is, I like to type in, just a number here. If you're not getting a thing that pops up that tells you like the dates, it doesn't mean they're not going to get them, but it's kind of like, it fills me with unease. You know what I mean? It's like, what do you mean you don't even know when you're going to get the next reel in? So that's when, I think we even booked some, and we haven't gotten them yet, but we ran out, and so we have to find an alternative. So, when you're doing this, use the product attributes to select an alternative. So we're going to guess it's going to be a single MOSFET. It's going to be an N channel. Now, I'm not going to click active. This is a secret, because I did at first, and I didn't find a good alt. And then I was like, well, what if I click non-active? And you'll see something came up. I want a MOSFET. Now, for the drain to source voltage and the current and the drive voltage and the RDS on and the VGS, again, I don't need it to be that precise number. I just need it to be around that number. So I'm not going to check those off. Instead, I'm going to then filter by groups, because it's like I just need 50 milliohm about or less, right? And less is better. So I can always select anything under that amount. However, I do want it to be a SOC 23.3. And I want it to be, of course, pick and place compatible. I want to use the same, package and PCB because I've already got that designed. Okay, great. So view so much. So 345 available. Now, even though I don't care about active, I do want it to be in stock. And that basically brings it down to 50. So, there's not as many of these in stock, not surprising. Okay, so next up, so the most important is that continuous current drain. Now, again, I mentioned, the LEDs, people can connect 3 to 9 watt LEDs. So I want to be able to draw, it was like 3.6 amps. I want to have something at least as good. So I'm going to select 3.4 amps, which is a little bit less, but still, well within reason, or above. And that gets me to 16 options. And then the next thing is the RDS on. So I do want to have the resistance be low. I mean, I really need to make sure if the thing that's going to be challenging is if I have to dissipate a lot of heat through this transistor. So I want to reduce the RDS on because it's not really heat sunk and it's driving a lot of current. So I had 50 milliohms before. And I'll basically select, 58 or under. So I'll give myself a little bit of a little bit more option, but still. For the VGS on, I think, let me see what it was. I think it was 1.7. Sorry, the VGS is 2. I will say that I'm driving it from 3.3 volt logic, so I'm actually not concerned. Nothing, I that's the one thing I'm really not too worried about. The VGS, everything here is under 3.3. So that's good. So let's see what we've got for options. So there are actually a couple options available, which is always a really good feeling. Let's see if there's any other. The VGS max I don't care about, and the gate charge I don't care about. So these are all pretty good. And then when I sorted down from stock, I actually got a lot of good options here. So looks like, one thing that I thought was interesting is that there is a DMG 3402. So this is a like a sister product to the 3406. And this one actually just has a slightly higher current. So it's actually a slight improvement, and it has a lower VGS. So this would be a really good option. And there's also the AO3406. And again, I always kind of like it when there's like a competing company that makes a chip with the same sub part number because it's like they're going to match the specs pretty well. Like I'm like, okay, clearly this was meant to be a drop-in replacement. Even though it's not guaranteed, even though you should check the data sheet, it's kind of nice, right? So it's kind of like, when you go to the grocery store and they're like, oh, they don't have Dr. Pepper, but they have like Mr. Pibb, and you're like, well, it's like a Mr. Doctor, PhD, whatever, it's close. So all of these are quite fun, but these three are going to say are the top picks because they have, I need a lot. They have over 40,000 in stock. The DMG3402, I would probably actually want to test it just to make sure it worked. But for drop-in replacementness, the AO3406 is another really good option. And what's interesting is that this was NRND. But they have 40,000 in stock, and again, I don't really care. I just have to get through the next couple months until that order that I placed for the DMG 3406 comes in. So there's definitely going to be a lot of pick around, find the right component to match. But for MOSFETs, when you spec them, I'll say it's tricky because there's so many specifications, and some of them matter and some of them don't. Like, because this isn't driving anything high speed, I don't worry about the gate capacitance so much, but that might matter to you. And again, like the voltage, the gate threshold doesn't matter. And I know the DMG 3406 has worked really well. So even though there's a chip that has slightly better specs, I'm actually probably going to be safe and stick with these specs just so I don't get surprised by something. Even if on paper something looks better, I've learned do try to stick to the thing that's closest to what you've got, and then change over specifications if you need to.
And that's a great search.
Where in the world is that part I need? The great search with DigiKey.
Okay,
I'm going to wrap it up.
Question came in.
Yeah.
Unrelated question if you're taking them today. Yes, we are. Bought the SGP30 board recently, and the LED on it is different than every other STEM QT board. It's not red, not green. Is the on LED color difference intentional, irrelevant, or perhaps simply the wrong slot for the SMD LED reels chosen for the pick and place that day?
It's on purpose because I believe that's a 1.8 volt power supply, and so it would not light up a green LED. So we picked a different color, which was red.
All right.
And check out Colin's video to find out why you have to use a red LED if you have a lower voltage.
All right. That's the show for tonight. Thank you, everyone, so much. I, again, want to say a special thanks to everyone who's always in the Desk of Ladyada chats and more. You're the reasons we do this because sometimes it's rough out there, but y'all are good.
Yeah.
So we're going to see everyone next week. It might be Saturday, it might be a Sunday. Unknown because there's a lot going on.
But that's the deal with Desk of Ladyada.
It's hacker time.
It's hacker time.
It's hacker
right?
time.
I don't know.
And we very much appreciate it. And thank you, everyone who, once in a while pick up some in the store because we want to keep doing this. And, we got some skills, got to pay some bills. So we'll see everybody next week. Bye-bye.
Bye, everybody.